Today's Christmas, and it's a Merry Christmas. I got my shirt on, it's Christmas, I've got some coding socks, I'm ready to go. I'm traveling, and yesterday when I got off the plane, I heard about the Advent of Cyber, which every day for 25 days they release a new capture the flag problem, and I thought, even though I'm a little bit behind, 24 problems behind, figured I'd give it a shot, see what I can do, take down as much as I can at a time, and I figured that I'd do a little bit of speed hacking, see if I could challenge myself to do 6 problems in under an hour, because I only have an hour before I have to go do some stuff with my family for Christmas. Unfortunately, when I recorded the video, my computer crashed midway through. The sound cut out. I don't have any sound on the video, but I'll do my best to voice over it and explain what I'm doing. But here we go.
This competition is a Jeopardy style competition. So there's web exploitation, cryptography, forensics, binary exploitation, reverse engineering, and open source intelligence problems every day. And every day they release at about 3 p.m. Now today is the 25th, but it's before 3 p.m., so the final challenge hasn't been released yet. I've gone ahead and I've picked 6 challenges: logical exclusivity, festive encoding, Apple Fanatic, Jets, EpoCrypt, and RESA. Of those challenges, logical exclusivity, festive encoding, EpoCrypt, and RESA are cryptography challenges, and Apple Fanatic and Jets are web exploitation challenges. I'll go ahead and I'll start the timer as soon as I click on logical exclusivity. Now, I'm not going into this challenge completely blind. I've looked through the problems and I've clearly picked the 6 that are easiest for me. But here we go, and we've begun. It says rotten beginnings, and it gives us some hex encoded values. And it says that the encoding is a logical operator and that maybe we should use CyberChef. Obviously to me, this just screamed XOR. So I go ahead and I hop right into CyberChef and I load up an XOR brute forcer. We can go ahead and we can turn the hex encoded values into bytes, and then we can go ahead and we can XOR with a variable key using the XOR brute forcer in order to look through options. Now in the options, we may not have exactly what we want, as we'll see later, but we'll be looking for something that has 3 letters, which would represent CSD. All flags are in the format CSD. And then an open bracket. Since we've gone ahead and we found one now, I'm going to go ahead, and since it's not in the exact same format that we want, we know that it's cal, open brackets, we're going to look through a ROT13 brute forcer for CSD. And we've gone ahead and we found it. Now we can go ahead and submit it. And that challenge is pretty easy, but that's why it was the first challenge. Just checking it out. Next we hop into festive encoding. In the text file that we have here, we have a 2023 decoded, 2023 encoded, and 2024 encoded. Now, we see that the encoding is using some emojis, or whatever you want to call those. And we can kind of start thinking, how are we going to map the emojis from the 2024 encoded back to letters? So I'm going to go ahead and I'm going to make a directory here so we can start working in there. And I'll go ahead and I'll download that festive encoding. But the idea that I had immediately was that I wanted to use a dictionary, and I would simply store the values from the festive encoding emojis and the map between those and the letters from the 2023 encoded and decoded. And using that, I would be able to get closer to decoding 2024 encoded. Now, as you may know if you've watched another one of my videos, is that I love working in Python. I think that it's one of the easiest and best, most open source scripting languages that has thousands of libraries to help you with everything. Here, one of the ones that we'll end up using is Unicode data. And that's because it can help to process these emojis. Emojis that sometimes when we're looking at it will have values that aren't real. So it kind of adds in an extra set of bytes in there and messes everything up when we're trying to map it one-to-one. But using Unicode data, as we'll use later in here, we'll be able to get around that because we'll be able to check and clear out those empty bytes that are just markers for where the data goes. And we need to make sure that we're importing everything as UTF-8, but here I kind of forget the Python syntax in here, so I go ahead and I check and see that we need to declare that it's encoding and not just say that it's UTF-8. You can see that we've already gotten out the encoded and decoded, and we can go ahead and we can split those using a built-in split, since they're each so nicely put with this encoded and decoded wording. Seeing as I didn't like the white space, and since the punctuation wouldn't transfer over in the encoding, I went ahead and I decided that I would just replace all of those characters with empty spaces. And I'd strip all the spaces, I'd strip all the new lines, all the tabs, and I'd strip all the commas, exclamation marks, apostrophes, and periods that were in there. That way we could just be working with strings of letters. It would make it easier for me, and in the future, we wouldn't have to deal with anything. Here we got Unicode data, and what we're looking for is Unicode data.name. which will be able to tell us if we have these markers that are in the text that don't really mean anything. Right now I'm looking to see the actual name of those values that we don't want, and you can see that it's variation selector 16. Now that's not actually an emote that you can see in there, rather it's just in there so that the computer knows how to process these and it can kind of separate out these bytes, since usually for these emojis, these bytes, they actually take up more space than you'd expect. Or rather more space than a normal character would take. So we go ahead and we decide that we're going to strip them out using one of these great Python things where we just build out our list without having for loop, or actually inside. And then we can go ahead and we can use join to join those all up together. And now we shouldn't have any of these variation selectors in there. We should just have only those emojis that we're going to map one to one. My worry though is that they won't be of the same length. So I go ahead and I check that, and we'll see that they actually aren't at the same length. And that's just because they were given different lengths in the encoding. I think it was Dear Santa or something wasn't included in the, or maybe it was Merry Christmas Santa wasn't included in the encoded text. You can see that it's 5 off. So it's probably just Santa. But that doesn't really matter. We don't need the Santa. We can go ahead and we can do it without, because I'm sure that there's already an S and an A and an N and a T in there. So we use the smallest length one, which is our encoded values, and we're going to go ahead and we're going to iterate through that and create a dictionary that maps them one to one. Now we've gone ahead and we've created our mapping. So we can map this deer to a D, bell to an E, Santa to an A, and the bowling pins to an R. Which is great, because now we have a dictionary that we can use to decode 2024. We go ahead and we put in this 2024 cipher, we grab it out, and we'll be able to iterate through it letter by letter and see if those things are actually in our dictionary. And if they're not, we'll be able to go ahead and print them out normally. And if they are, we'll grab the decoded values and we'll print that out. Now, a problem that we end up running into is that not all of our values are in the dictionary. We haven't decoded all 26 letters of the dictionary, or of the English language. Instead, we have some that are missing. But rather than figure out some other way to get around this, we'll go ahead and we'll just do it ourselves. You know, if there's only one letter or sometimes 2 letters missing, we can go ahead and from context probably grab what those letters might be and map them to the emojis. So I'll go ahead and I'll build out that dictionary all on my own. See here, we think that the camera's a W, the bell might make out no, and above that we have kid, or those streamers. So we'll go ahead and we'll say that that D is a K. Later we see in the white van with those claps, that's probably a V, and this probably says sign. I don't know many other words that go SI blank N. So here we've grabbed a G and we've grabbed a V. see immediately Holly Jolly Christmas, so that's pretty easy to figure out. And probably have Don't Forget. So that G that we saw earlier, I hadn't figured it out yet, but now I go ahead and I see that I want G there. And I'm going to go ahead and print everything back out so I can take a closer look at it, and we're still missing some of them. Now obviously this tree is going to be a B because we have but before there, so that's not too hard, but we do end up missing one still. We don't have all of the letters. We see CSD, big, jaw, bow, wet. We don't actually know what that is. So I'm going to go ahead and I'm going to look through all of them, all of my values in the dictionary, and see what letters I might be missing, because I assumed that they're one-to-one mappings. You know, you wouldn't want to map 2 emojis to one letter. That would be a little bit too much and be hard for it to do. So instead we go ahead and I go through and I want to print out all of the values that I'm missing. We see that we're missing a Q, an X, and a Z. So it could be any of those. Now, I don't know any words that go B-O-Q or B-O-Z, but I do know box, B-O-X. So I go ahead and I say that this is an X, and after decoding it fully, we see that we're missing nothing left, even though my head takes up most of the space here. But that's the flag, and I'll go ahead and I post that in. And we've moved on to the next challenge, Apple Fanatic. Now this is our first web challenge, and web challenges are notoriously pretty fun, but also pretty easy. The description reads that this guy who built the website loves Macs. And in the hints, we see that it says, look for a secret file. Now, I've done a bunch of these challenges before, and the secret file always happens to be DS Store when you're working with Macs. And those basically go ahead and give you some information about the directory that you might be looking at here. I don't see that right away where I might put that in. Rather, I look at the sources first, and then I see that there is a secret script that asks to use a Mac. And so I go ahead and I say that my user agent is a Mac. While I'm figuring this out, I see that I've actually already done something exactly like this challenge before, and I've gone ahead and I had a user agent already in there that had Mac, so I can easily just say use this. Now I refresh a couple times and I realize that it actually doesn't change anything, and so I go ahead and I check, am I missing something? And I can go right into the console and I can check it out. I say print this out, see if it has Mac. Is this true? It is true, I do have it. Now that must mean that this input that we're grabbing from document get element just doesn't exist in there, because nothing's actually loading for me, and it doesn't. It returns null. Instead, I see that there is a file called my script vault of scripts, or my secret script vault of scripts and files, and I go ahead and I go in there and I know what I'm looking for. I'm looking for DS Store, and I go ahead and I download that. I just put that in there. Say, please give me DS Store, and it downloads it. Boom, we've got DS Store. Now it's the second one because I've done this many times before where you're just looking for DS Store. It gives you the directory you're looking at, and then you can grab whatever file you want out of there. So what I have to do is I have to go and look in DS Store and see what strings it's going to have in there, what files might be in there. Now you can use Python to go ahead and look through that, but honestly that seemed like it would take longer to me. So instead what I did is I just printed out the whole DS Store values, and I went ahead and I looked at it myself. Now that I've moved it over and I've gotten rid of these pesky zone identifiers that happen in Windows, I can go ahead and I'll just cat it out, look at it, and I see immediately the birth date of my beloved appletree.txt. Now that's clearly a text file in there, and I bet if I went through and I looked at it in Python, it would say that that's one of the folders in there. Now strings didn't really do me much good, but I'd already seen it. So I went ahead and I grabbed it and I looked in there. And I just put that in. Boom, we've got the flag right there. Pretty easy to see. It's CSD, blah, blah, blah. And I can go ahead and paste that in. That's one more challenge completed in 19 minutes, 58 seconds. Now what happens next is that my computer crashes here and all of the data for my recording get destroyed. But that's all right. I'll jump back in with the next video when I start back up. Well, I've gone ahead and I've turned my computer back on and I've set everything back up so that we just have Jets, EPO, Crypt, and RESO left. Now, Jets, again, is another web exploitation problem, and it says look at scripts.js. While I'm getting everything set up, I was explaining my computer just died randomly. Unfortunate that I lost the sound, but it's alright. We've gone ahead and we've started, we've opened this up. We see Jets here. But I wanted to open it up in a new tab, so go ahead and reopen that. Now I'm looking in the sources directory for the scripts.js that they gave us. And right away I see that, if I can make this a little bit bigger, that they've gone ahead and they've left in their secret for their JSON web tokens. So I can easily sign my own secret using this base64 encoded value. And I also see that it's looking for sub equals this other base64 encoded value. I can go ahead and I can decode those values, or I could just use them as base64, not to matter. But I go ahead anyways and I make a new directory, or I just hop it right into Node.js, and I see that I'm looking for Kunal. Now this ends up being a theme for a lot of the thing, is we're looking for these Kunal. Now, I don't really know who Kunal is, but he seems to appear a lot. So, I guess knowing now what I know, having done some more of these problems, is that we're on the right track. Now, I go ahead and I hop right into jwt.io. Great website, helps you sign tokens, all that. And I immediately go and I put in Kunal, and then I want to sign it with my own thing here, my own secret. I can go ahead and I can do that pretty easily. Just paste in this base64 encoded value in there, and we should be good to go. Now what I'm looking for is what the token name's called, and it's actually token. So I go ahead and I put in that cookie, token equals this value. But I've actually made a mistake here, and see if you can figure it out. We'll figure it out in a second. The secret was actually that I had left in your secret token here that JWTIO provides. So it was signed incorrectly because I used a different secret. Now, it took me a second to figure that out, but once I did, I saw we have an F-22 Raptor, F-35 Lightning. I was just going ahead and looking at those for a clue. But we also have a Walmart bag that has this code right on it. So I just go ahead and I write that down so that I can put that in. Now, I go ahead and I try to submit this, but I guess my network is having some problems since I've been traveling. I'm sitting in an Airbnb right now trying to submit these, and clearly something is not working. But I figure, did I get it wrong? So I try one that I know is incorrect, but it doesn't say it's incorrect. So I figured the network just must be down. I try reloading this challenge. I make sure that I get it right first. But once I end up reloading this web page, we see that that's actually the code there. While I have some time on the speed side of things, our first challenge was 1:40, our second was 15 minutes and 39 seconds, and our third was 19 minutes 58 seconds. Now these are overall times, so on top of whatever Jet's time or whatever time you're seeing there, we will be adding 19 minutes 58 seconds, basically 20 minutes there. And overall, we took a long time on festive encoding, but our Apple's challenge really didn't take very long. These web challenges don't take too long. You kind of got to see it, especially with some experience, knowing where that DS store was. We got it. And I forget to stop the time for Jets again, but it's basically 5 minutes there for Jets. We'll go ahead and we'll hop right into EpoCrypt, and we'll make a new directory for EpoCrypt so that we can start going. All EpoCrypt give me is this Python file, which basically is the backend that you're having to communicate with through this port, and it uses some time-based encoding. Now, obviously, we won't be able to get the exact time on the machine, and we won't be able to encrypt text and view the encrypted flag at the same time, but what we can do is we can use a known plaintext attack. Now what that means is that we will provide our own plaintext, and we will get the encoded value out using this number 1 option for encrypt text. Because of that, we'll be able to decode the time that it's using in there. And while it may not be the exact time that we went and we got the encoded values out or the encrypted flag out, it will be pretty close. So we'll be able to use that guess at a time in order to iterate through and use the actual time, especially because here it takes the time as an integer in EpoCrypt. You can see here it says integer time.time, so we're not having to work with that different of numbers. We're just looking at these integers and seeing, as I didn't call them hours apart, they should all be pretty similar. Now what I'm going to do is I'm going to start up a new Python file where I can build out a decryption algorithm. We can see that the encoding method that they've created, which never make your own crypto, is that we have these encrypted text. We change them by 3 and modulus around 1 whole byte. And then we go ahead, we base 64 encode it, we grab out this encoded key, which is this time.time. And finally, we XOR those together to make our final, and we print it back out as hex. Now what I'm doing here is I'm reversing that. So what we do is we change that hex value back to bytes. We grab our encryption key, that EPC, that EPO, whatever, and we get back out our based, which is our base 64 encoded. We try to decode that, and finally we subtract 3 to get our final encrypted value so that we can return it. But I know that we also need to use a known plaintext attack to get the time that they're using on their system. We actually don't know. I mean, they might have a different time setup than we do. It might not be working on, it might be working on UTC, whereas I'm on the East Coast, so I'm Eastern time. So instead what we do is we work from both sides here. We have our final, we know what that is. We have our based, we know what that is because we've created our own encryption. We're creating our own encrypted values. Now what we need to do is we need to get EPC out. Since our XOR value is deterministic, we can easily just work for any of those using any of the other two. Using any of the other two, we can get the third value, kind of like you do using the big four equations in physics. I'm sure that there's some built-in thing to go from bytes to hex, especially using Pwn, but I like to write it out myself, and I've done it thousands of times, so it's really not all that difficult for me to end up doing here. But essentially what we do is we grab every two characters, we interpret them as base 16, which is hex, and then we turn them into a character and we add them to our result. Now I did want to make sure that my thing worked first and that I was actually able to turn hex to bytes. So I wanted to go ahead and print it out first. And obviously we're having some problems here with syntax, but that's just because we're going as quickly as we can in order to solve these challenges as quickly as we can again. See here we have another problem where we didn't put encryption as bytes, but it ended up working, our hex to bytes, so we can finally go ahead and we don't actually need to print final again. We'll just go ahead and XOR. We can see here that we do get a timeout. Now it might be too small, and we're not exactly sure based on this encoded value here. We might be using an encoded value that's smaller than we actually want. So we can go ahead and we could always use an encrypted value that is much longer. Say instead of secret, which is 6 long, we use something that's, 60 long, or maybe even just 12 because we're not going to have times that are that big, but something that's bigger. Here we have problems because it won't base 64 correctly, and that's just due to us having the wrong time. Now, I know that, but I want to go ahead and check again that we're doing the right thing here, and we're going to go ahead and we're going to work through these times. Now, I chose some bad variable names, so I'm going to have to deal with that. But what we do is we iterate through these times, and I know that I asked them to encrypt my text first, So I go ahead and I look for the next 10 seconds because I figure it couldn't have taken me that long in order to get the values. And we go ahead and we throw in a try except because I don't want where we have problems. Unfortunately, we do have more syntax errors in the code or something of that form. And what ends up happening is that I actually used the encrypted value that I asked them to sign rather than the encrypted flag. So we don't really get anything good out there because we're working from this T and we're having some problems. Now, I'm struggling to see that at the moment, so I go ahead and I look at it, and we get all of these invalid paddings, and then we have an invalid base64 encoded string. So I assume that the incorrect paddings mean that I'm looking at the wrong thing, or that I'm using the wrong time, and that these invalid base64 encoded string means that I have a code or a time that is, at least functional in the base64 sense. I go ahead and I re-grab them out and I want to get more values here. I actually end up using a bigger string, I think, here. Let's see. Yep, this is a flag. Or this is a secret flag. That way I'll be able to get these times out more accurately, and I want to grab the flag, the encrypted flag, as close to it as possible so that these time.times calls are as similar as possible. Now here is when I realize that I'm actually not using the right encrypted flag value when I'm doing these full decrypts. Rather, I keep using this final that I've already coded, which I know should always get back out to this as a secret flag. But again, I have the time, and it will repeat over and over again because of the way that the XOR value works for pwn tools. So I go ahead and I just look at it myself. I see, we probably had the right size time. We were probably working in the right area. But here we go again, and this is going to be our T. Go ahead and change that. And I've upped the difference to 30 in the T there, just in case, we can look through more values. It really doesn't take that much more computational effort. When we finally use the right value, we see that we're actually getting things that could be right, and I no longer want to print out these exception as E, I just want to pass again. We're using the actual encrypted flag value, so we see all these, and I immediately say to myself, we're going to be using full characters that you can type in, so we're not going to have these XF0 or X00, because obviously that ends a string, or XA6, Also, we probably won't have any of these apostrophes or @ signs in here. So I go ahead and I clear those out so that I can look at what's left. After doing that, we can finally use this number 3 option you see on the right here in the menu page, which says check flag. And we can check that we get the right flag. Now they know that you could always have, based on the time and based on what we're encrypting, multiple options there. So they don't want us to have to try all of these options, I think you can only submit a flag every 13 or every 30 seconds, maybe every 15 seconds, I can't remember. Instead, we can just go ahead and we can check flag, and we can see if it's something that we want. Now, again, I'm going to end up having a syntax problem here because I forgot to make this into a list. So when we're calling all C in printable, we're actually not doing it. We also have that we're using a string there. Finally, we have a couple options here, and I just go ahead and I ignore any of the ones with punctuation. We're going to try this D3, FP, and then it looks like made by an elf. So we go ahead and we try defp made by an elf first, and then we go ahead and we try defo made by an elf. Now, saying those aloud, you can tell that defo is definitely, so it's probably that one. But, you know, I'm rushing through. I just want to see how quickly I can do it. So the first one we try is wrong. Second one we try here ends up being the correct one. Boom. So we can go ahead and submit that. 18 minutes. That means that we spent 13 minutes on this EPO here because we spent 5 minutes on the first one. I think I recognize that I forgot to do the timer there. So it took me another second to double tap it. We hop into RESA, and I immediately make a directory because I figure it sounds like RSA. I'm probably going to be working with these text files. It provides us this encrypted stuff, and we want to be looking through that. Now, it says that we're missing a Q and we're missing an E, but what we end up seeing is that we're provided an N, a C, and a P. Obviously, from N and P, we can immediately get out the Q. We just integer divide that, not too bad. But this E is a little bit more problematic where, luckily in the hints we see that E is within 50. So we can only use numbers through 50. And eventually we do end up finding out what E is. Now we go ahead and we make this Q is an integer divide P. We can immediately make our new modulus for decrypting E, or getting our D from our E, which is this phi, P minus 1, Q minus 1, where P and Q are both prime numbers. Luckily, I know that SymPy has mod inverse, and so I can go ahead and I can say that D is going to be mod inverse of this using this phi and this E. Then using all that, we can decrypt it with our C to the D N. And I usually can't remember some of these built-ins here. So I think at some point here, I go ahead and I use ChatGPT in order to help me with the syntax of decrypting. Now, E has to be co-prime here, but I figure, if we're only looking through these 50, I don't really care if we run into some errors with D or with this mod inverse when we don't actually have a co-prime. So instead, we're probably just going to use another try except in order to get through it a little bit quicker. Now, I think ChatGPT is a great help in some of these challenges, especially for some Python syntax or built-ins there. I ask it, how do I get bytes from integer? And now it's going to give me some whole excuse because I asked it a bad question. But, now I'm going to specify that I'm doing RSA, and I have this integer that I've decoded, and I want to turn it back into bytes. And it'll go ahead and it'll give me this syntax, which is great, that I would have forgotten otherwise. I could look it up, but it's easier if I just get ChatGPT. It'll give me these code snippets, it'll look it all up for me, make it a little bit nicer. can see here we run into those coprime problems where, the modular inverse of 3 does not actually exist in that sense. So I go ahead and I say, ignore those ones then, and only give us the coprimes or only give us the e's where they are coprime and the modular inverse does exist. The problem here is that, once again, I have some syntax errors in there. Really, it's not a syntax error. It's that I use this decoded integer instead of plain text, which I call it. So it doesn't exist. Once I do, I have all of these values printed out with these different e's, and we can go ahead and we can look through for one that looks like our flag. I just go ahead and I scroll through and I say, where are these ones that's just going to be CSD, that's going to be easy for me. Obviously it's not going to be that big. So I'm scrolling through, I'm looking for CSD, the format of our flag. It'll be one of the smaller ones here, and we've actually seen one here. This VESA, RESA, RSA, I don't even know. The thing is, that might not be the only one. So I go ahead and I want to see if it starts with the CSD, and if it does, then I'll go ahead and print it out. Otherwise, we don't need it. After that, you can see that there's actually only one option, which is the one that we saw before. So may have wasted a little bit of time there, not that it really matters. And upon submitting that, we see that we've gained 80 more points, which is brilliant. We've stopped in 24 minutes, 53 seconds. That means that going ahead and looking at the challenges that we've done 6 challenges, 4 cryptography and 2 web challenges in 44 minutes and 51 seconds. On the leaderboard, that makes us 77th out of about 330 people, which I'm pretty happy about. As always, you can find my write-ups for these problems on my website, Tilden.me, and I hope you learned something, had some fun.